Hello, in this video, we will talk briefly about regression methods using R. So regression is a kind of statistical model, and it is also used in, for example, machine learning. So this is a simple regression model because Y is dependent variable connected with only single independent variable. But we can also add more variables here, x1, x2, and so on. So this is called multiple regression model. And the main job for the regression model is to estimate the coefficients alpha and beta. So this is the often used methods for estimation called ordinary least squares, because the method focuses on to minimize the least squares summation. So here EI is this place, the difference between the actual value and the predicted value. So this is the regression line from the previous page we got. And for each observed value, there is a regression value. So the difference between these two called EI or residual. So we take a square of each of them and summation. So minimize this term will get the best coefficient for the model. So next we will show an example for the medical expense as dependent variable and the other variables as independent variable. So along the way you can download the source files from this website, and this is also for the Python and R training. So you can go to the download menu, you can find the links for this file. So we go to this file and go to the part for example, set the working directory, and you can change this code for your working directory, and we load a data file called insurance CSV. So this is a data frame, and we show this data frame's structure using str function. So there are about 1,338 observations and with 7 variables. So the age, sex, BMI, body, mass, coefficient, index, and children, and smoker, and the region. These are factor variable. So smoker has 2 levels, for example, no, yes. And the region has 4 levels, north, east, northwest, and so on. And other variables is expense and BMI, both are numeric variable, and sex also factor variable. And age is integer variables, and children is integer variable. So how many children in your household? So we go step by step. So first we will show summary information of this expense variable, because this is a dependent variable and we hope it is like a normally distributed, but not exactly you have to a normal distribution. But if it is normal, it's good, but it's not normal, that means it's not good. So summary show the minimum value and median, first quantile, third quantile, and maximum. You can see these two different, so which means the data has some skew. So we show the histogram again. So you can see the long tail on the right side. This is a positive skew for the expense. And we also show a categorical variable region using table. So they are quite good for evenly distributed for the 4 region. Then we can show the correlation between these 4 variables. So you can see, for example, age and expense had 0.3 positive correlation, and expense and BMI about 0.2. So these are symptoms that we have to add these two variables in the model. And another function is called pairs. This will show the sketch plot for the variable pair. For example, this is the age and expense has a positive trend. But anyway, it's very difficult to see explicitly between variables, and BMI and expense has somewhat changed. Then we can use another function from scikit package. This is called pairs panel, which is combining the sketch plots and correlation coefficients in one plot. So on the up part is the correlation between variable pair, for example, age and expense 0.3 and BMI expense 0.2, and the lower side is same as the previous function we showed for the sketch plot pair between each variables. And here also has a line, red line in each figure, which is like a fit line between these two variable pair called the Lewis curve. So next we can set up a model. For example, we can include all other variables in the model and with expense as dependent variable. So LM for the linear regression function in R, then expense on the left side of this symbol. This is the tilde symbol. Then on the right side, we add all the variables. Then with a comma, then data equals insurance. It's quite clear. And you can also use this way if you want to add all the other variables as independent variables. So you can just LM expense, same on the left side of the tilde symbol, and on the right side we just use a dot, then comma for the separator, then data equals insurance. So this will create same model. Then we just show the model because this is run. So the model is run and show the results. It's very easy to understand. So just intercept, and we just can do not think about too much about the intercept because it's not real meaning. Then age each coefficient for each variable. And you can see the sex male here because sex is a fetch variable. So this will create like a dummy variable. Dummy means this is the value for the male in the sex variable. So compared with the reference level of this variable. And the reference level of the sex variable is female. So which means other variables hold constant. The male will have less expense than the female. And similarly, for these three variables, actually this is a value for from the variable region. So R will automatically add the region northwest, region southeast, region southwest, because the reference level is the first level of region variable called northeast. So you can see each of these three dummy variables will have negative value, which means they have less expense than the people in region northeast. And for the other variable like age, BMI, children, they have positive, which means BMI holding other variables constant. Increase of 1 unit in the BMI will increase 1 unit in expense, same as these two variables. So now we will make the model better, but before that we just show the summary. Summary of this model will have several parts. The first is a residue. can see this is the total residue, or the minimum to first quartile median and the maximum value, and the coefficients for each of the estimates which we have seen in summary of the in this function, and the standard error and the t-value, but most importantly the p-value here. So p-value less than 0.05 will be significant for this variable. But you can see here these two are not significant, and this 3 star, which means highly significant. So this is exactly the like the statistical estimation results for R squared. So R squared, adjusted R squared or R squared means about 75 of the variation in expense variable can be explained by the other variables in the model. So next we can get the model better performance, because for example on the C-array we think age will be squared also added into the model. So we can create a new variable called age2, which is the square of the age. So we create this new variable first. Then another variable we can create called BMI 30, so which means if the BMI larger than 30, we will add another variable called BMI 30 is 1. So both BMI and BMI 30 we will add in the model, or we just can see. So now we can create a new module called ins model 2, use same function lm, and expense on the left side and the right side we add extra variable age2 and BMI. Then we add also another variable. Sorry, we will just add age2 and BMI and smoke interaction. So interaction means this variable will consider the interaction value pair between smoke and BMI, right? So this is a little complicated effect. So this is based on the theory. So if the person has a BMI over 30 and he also smoke, so may have very high expense for the medical care. We just run this model and show the summary. So you can see now the little change for residue much less, and several variables are significant than before. And the most important is R squared is significantly higher than the previous model, but from 75 to about 87%. So this video just showed the estimation step of the linear regression model. Thanks for watching.